Good morning, everyone. This is Chandra Mohan, Assistant Professor of Mathematics, Department of Freshman Engineering, St. Martin's Engineering College. Now, today I'm going to explain about double integrals and change of order of integration. So, coming to the introduction, in lower classes, already we have studied about how to use definite integrals to find the areas. Now, here we are going to learn how to use double integrals to find the areas. So, this means double integrals and triple integral comes under multiple integrals. So, where definite integral, it is an extension of the definite integral. So, definite integral is a function of applicable only for the function of single variable, whereas double integrals are functions of the two variables and the triple integrals are functions of three variables. So the generalization of the double integral for two dimensions is called a double integral, and it is for three dimensions it is called a triple integral. So after learning how to evaluate double integral and triple integral, so we can able to evaluate areas, volume, center, mass and moment of inertia for a plane and some solid regions. Now I'm going to explain how to evaluate the double integral through board. So let us see how to evaluate the double integral. An expression of the form integral, an expression of the form integral a to b integral y1 of x to y2 of x f of x comma y dy dx. This kind of integrals are called as iterated integrals, or integral a to b integral x1 of y to x2 of y f of x comma y dx dy. These are called iterated integral. If you see the first iterated integral, you can see the interior limits. Here what are interior limits? Interior limits are functions of x. So then we have to take them as y limits. Okay, so interior limits belongs to y, then exterior limits belongs to x. If you take second iterated integral, the interior limits are functions of y, then we have to take them as x limits, and then exterior limits belongs to y. Now let us see how to evaluate these type of double integrals. So integral a to b integral, the interior limits are the functions of x, then we have to take them as y limits. Y is equal to y1 of x to y2 of x, then exterior limits belongs to x. So x is equal to a to b and the integrand is f of x comma y. So first interior limit, we have to see interior limits. Interior limits are y limits, then first always with respect to y, then with respect to x, dy, then with respect to dx. So first integration with respect to y, then with respect to x. Between the limits y is equal to y1 of x to y2 of x and x limits from a to b. Like partial differentiation, already we know that what is partial differentiation. So when partial differentiation means when differentiation with respect to x, treat y as a constant. Then with differentiation with respect to y, we treat x as a constant. Like that, here we are introducing partial integration. So while integration with respect to y, we have to treat x as a constant, and integration with respect to x, then treat y as a constant. If you see this iterated integral, the interior limits belongs to y, then first integration with respect to y, then treat x as a constant, and then exterior limits, and the resulting expression we have to integrate with respect to x between the limits a to b. Now coming to the second iterated integral. So let us see how to evaluate this integral. Integral x is equal to x1 of y to x2 of y. Interior limits belongs to x. So x is equal to x1 of y to x2 of y. Why we are taking these limits as x? Why? Because these are functions of y. Then we have to take them as x limits. Then exterior limits belongs to y. Y is equal to a to b. And the integrand is f of x comma y dx dy. So here interior limits are functions of y, then we have to take them as x limits, then always first integration with respect to x, with respect to x, and then the resulting expression with respect to y. So this is a way of double integration. And if all the four limits are constant, then how can you do double integral? Okay, let us see. F of x comma y dy dx. So in case if all the four limits are constant, then we can integrate, we can follow any order. That is either first integration with respect to x, then with respect to y, or first integration with respect to y, then with respect to x. So that's why we can take any order. X is equal to, like x is equal to a to b, and y is equal to c to d, f of x comma y dy then dx. So here I am taking the interior limits belongs to y, then first integration with respect to y only, then between the limits c to d, and then the resulting expression with respect to x between the limits a to b. So this is the way of integrating in double integration. This is applicable only for functions of two variables x comma y. Now coming to the next slide. So we have to identify the region to find the limits. That is very, very important, identifying the region between by using the limits, given limits. So if the limits are constant and when the limits are variable limits, so let us see how to identify the required region. So if you take the limits like x c to d and pi 1 of y2, pi 2 of y, f of x comma y dy dx. See if you take this type of double integral, here the limits are c to d, pi 1 of y2, pi 2 of y, f of x comma y dy dx. Here f of x comma y is unknown function, and interior limits are functions of y. Then we have to take them as constant. X is equal to, we have to take them as x limits. X is equal to pi 1 of y2, pi 2 of y. Then exterior limits belongs to y. Y is equal to c to, y is equal to d. So we have to draw all these four limits to get the region of integration. So in this figure you can see the required region of integration. So what are the limits? First we have to take y is equal to c, y is equal to d, and variable limits. X is equal to pi 1 of y, x is equal to pi 2 of y. Okay. So now we have to draw by using all these four limits. Here x limits are variable limits and y limits are constant. You know already y is equal to c. Y is equal to c means it is in the form y is equal to k, line. It is a line equation. It is in the form y is equal to k. So then it is parallel to x-axis. So you can see in the figure y is equal to c, which is parallel to x-axis, and y is equal to d, which is also parallel to x-axis. And we can draw the curves. X is equal to pi 1 of y, x is equal to pi 2 of y. Now we have to identify the region which is bounded by these two lines and these two curves. Okay, so here what is common region which is bounded by two lines and two curves? So this is a required region. In this region we have to integrate. In this region we have to take the limits. Okay, so this is about region of integration. Next, coming to the types of regions. There are two types of regions, type 1 and type 2 regions. So type 1 region means, you can see, so there are two types of regions. So type 1 and type 2 regions. So in type 1 region, the region which is existing in two vertical lines. You can see here x is equal to a, x is equal to b. This is x is equal to a and x is equal to b. The region which is existing between two vertical lines. You can see, which is x is equal to a and x is equal to b. So between two vertical lines, the region is existing. This type of regions are called as type 1 region. And coming to the type 2 region, the region which is existing between two horizontal lines. You can take You can see these two are horizontal lines. Here the region which is existing between two horizontal lines, x is equal to h2 of y, x is equal to h1 of y. This type of regions are called as type 2 regions. This is very, very important to identify the region, to find the limits, then only we can evaluate the double integral. Next, coming to the next one, here there is a sketch the region of integration and then evaluate 0 to 1, 0 to 2, y square x dy dx. If you see this double integral, here all the four limits are constant. If all the four limits are constant means you will get a rectangular region. You will get a rectangular region. It is as shown in the figure, you can see. So this is a required region. See, x is equal to 0 to 1 and y is equal to 0 to. I am taking, you can follow any order. First with respect to y, then with respect to x, or with respect to x, then with respect to y. Here I am taking interior limits belongs to x. Interior limits belongs to x. So interior limits are x is equal to 0, x is equal to 2. Interior, then outer limits belongs to y. Okay. So see, interior limits. So then here, while integration with respect to x, interior limits belongs to x, then first integration with respect to x. So here y square treated as a constant. Then we are taking out y square and integral x dx is x square by 2 between the limits 0 to 2. Okay. So after finding limit integration, then apply the limits. Okay, so what are limits here? 0 to 2, upper limit is 2, lower limit is 0. Then just substitute the limits, upper limit minus then lower limit, 2 square minus 0. So 4 square by 2. Okay, taking common 4 by 2 and then the resulting expression. Here we got resulting expression in terms of y and also integration with respect to y. So between the limits 0 to 1. Okay, so here the integrand became y square. So what is integration of y square? Y cube by 3. Okay. So then take the limit 0 to 1, substitute the limits, upper limit minus then lower limit. Here upper limit is 1. So 1 cube means 1 by 3 into and minus lower limit is 0. So for 0 it is 0. So finally we got 2 by 3. This is the value of this double integral. Okay, you can see the limits of integration here. Here x is equal to 0, x is equal to 2, interior limits, x is equal to 0, x is equal to 2 and exterior limits are y is equal to 0, y is equal to 1. So x is equal to 0, nothing but y-axis. On y-axis x coordinate is 0. So this is x is equal to 0 and x is equal to 2. X is equal to 2 means which is parallel to y-axis. So this is x is equal to 2 line which is parallel to y-axis and y is equal to 0. On x-axis y coordinate is 0. Then it is y0. Y is equal to 0 on x-axis and y is equal to 1. Y is equal to 1 means which is parallel to x-axis. This is y is equal to 1. Now, so from these limits we can tell, see the limits. The y limits is extending from y is equal to 0 to 1. Take one vertical strip. Take one vertical strip. So which is sliding on x-axis, and extending from y is equal to 0 to y is equal to 1. So the limits are y is equal to 0 to y is equal to 1 and sliding along x-axis. So from left hand side to right hand side, it is sliding along x-axis from x is equal to 0 to x is equal to 2. So here x is 0, here x is equal to 2. Like that, we have to we can take the region of integration. That is very, very important, finding the region of integration. Next, coming to the next slide. Let us see for variable limits. For variable limits, See, 0 to 1, 0 to x. Here the interior limits are functions of x. Then we have to take them as y limits. Okay. So here y is equal to 0 and y is equal to x. What is y is equal to x? It represents the line equation. So which is passing through the origin. It will exist in first quadrant and third quadrant. Okay. You can see diagram. You can see the diagram. Here it is y is equal to x line. Okay. So which is passing through the origin. Okay. It will exist in first quadrant and in third quadrant. But here by using the limits, here what are the limits? Y is equal to 0, y is equal to x. Okay. So y is equal to 0, nothing but x axis. On x axis y coordinate is 0 and y is equal to x. So this is a line, y is equal to x line. And x limits, what are x limits? X is equal to 0, x is equal to 1. So x is equal to 0, nothing but y axis. On y axis x coordinate is 0 and x is equal to 1, which is parallel to y axis. X is equal to 1. Now you can identify the region which is bounded by these four lines. Y is equal to 0, y is equal to x is equal to 0, x is equal to 1. So this is the required region of integration. This is a required region of integration. Okay, so coming to the next slide. See, the interior limits 0 to square root of a square minus x square. So 0 to, it is a function of function of x. Then we have to take them as y limits. We have to take them as y limits. So y limits becomes y is equal to 0 to y is equal to square root of a square minus x square. Okay, here y is equal to 0 to y is equal to square root of a square minus x square. Okay, so y is equal to 0. It is nothing but x axis. On x axis, y coordinate is 0. Y is equal to 0. And y is equal to square root of a square minus x square. Means by squaring on both sides, we get y square is equal to a square minus x square. So it represents circle equation. X square plus y square is equal to a square, means it is a circle equation with center at 0, 0 and radius a units. Okay, so this is the circle with center at 0, 0 and radius a units. Then these points become points of intersections. 0, 0 with the center radius a. Then this point becomes a, 0 and this point becomes 0, a. Why? Because on y-axis x coordinate is 0, on x-axis y coordinate is 0. So this is the region of integration. We are identified. This is the region of integration for the given function. Okay, we have to find this region of integration for this double integral 0 to a, 0 to square root of a square minus x square, f of x comma y dy dx. Here f of x comma y is unknown function. That's why just find the limits and keep it. Now coming to the next slide. Change of order of integration. So change of order of integration describes the region of integration and accordingly the limits of integration. Okay, so change of order of integration means change of order of the limits. Okay, so if the integration consists, if the region of integration consists vertical strip and sliding along x-axis, then on changing the order we have to consider horizontal strip and sliding along y-axis. If the region of integration consists horizontal strip and sliding along x-axis, then on changing the order, we have to take vertical strip and sliding along x-axis. So in some cases, it is required to split the given region of integration and express the integral as a sum of the regions, sum of the subregions, sum of the integrals of the subregions. So it is always better to draw a rough sketch of the region of integration. And what is the use of changing the order of integration? So this is one kind of integration method to evaluate the double integral. Okay, so in all problems we can't evaluate the integral in some cases. So in that case, if we change the order of the integration, we can evaluate the double integral. That's why we are using change of order of integration. So just change of order of integration means change the order of the limits. So if the given integral, in the given integral, if first integration with respect to x, treating y as a constant, then changing the order, first we have to integrate with respect to y, then with respect to x. But if the given integral, integration with respect to y, then we have to treat x as a constant. On changing the order, first we have to integration with respect to x, then with respect to y. So this is the way of change of order of the integration. Now let us see how to change the order of the integration. So let us see this. This video shows us the difference between rectangular regions and non-rectangular regions. For changing the order, it is very important to draw the rough sketch of the region of integration. So the region may be rectangular region or non-rectangular regions. In case of rectangular regions, you can see this video shows that. So this is a rectangular region. So in this case, always we get the limits as a constant. We will get constant limits only for rectangular regions. You can see the limits as y is equal to 0 to 3, x is equal to 0 to 5. So we are considering the region in xy plane. Take xy plane and give the numbers 1, 2, 3, 4, 5, 6, 7, 8, and in y-axis 1, 2, 3, 4. Okay, so here if you take, see, the rectangular region, the limits are always constants only. The limits are constant values. Okay, so you can see the limits are constant. So how can you find the limits in for rectangular regions? I tell you. So here, see, x is equal to 0, x is equal to 5, x is equal to 0 to x is equal to 5, and on x-axis y is equal to 0, here y is equal to 0 to y is equal to 3. Okay, this is about rectangular regions. The limits are always constants only. You can see this is the non-rectangular regions. So in these regions, we may split the region into two sub-regions. Like you can see the video. Here we are dividing the total region into two parts. R1 and this yellow part and blue part. Okay, these are two regions and we are expressing the total region of integration as a sum of the regions. So these limits belongs to this region R1 and these limits belongs to this region, green shaded region R2. Okay, so and then the total region of integration that is expressed as a sum of these sub-regions, sum of these integrals of sub-regions 0 to 4, 0 to x square by 4, and for this 4 to 6, 0 to 12 minus 2x. You can see here all the four limits are not constant. The interior limits are variable limits. You can see for this region the variable limits are 0 to x square by 4. So for this region 0 to 12 minus 2x. So this video shows us the difference between rectangular regions and non-rectangular regions. So after that, so by taking one example, so we can find how to evaluate the limits, how to find the new limits by using the change of order of integration. So see this problem. So here the limits are, interior limits are functions of y, then we have to take them as x limits, and then exterior limits. Exterior limits are constant 0 to 1, then we have to take them as y limits. So x is equal to y, x is equal to 2 minus y, and y is equal to 0, y is equal to 1. Okay, so one limits are variable limits and one limits are constant. So according to given limits, the limits, interior limits are y to 2 minus y and 0 to 1. So here according to given limits, first we have to integrate with respect to x. Why? Because the interior limits belongs to y, belongs to x. Then first integration with respect to x, then the resulting expression with respect to y. Okay, so now on changing the order, what we have to do? We have to do first integration with respect to y, then with the resulting expression with respect to x. Now let us see how to evaluate the new limits, how to find the new limits. So to find the new limits, we have to draw the diagram by using these four limits. Here two limits are variable limits and two limits are constant. By using these four, we have to draw the diagram. Okay, you can see y is equal to 0. Y is equal to 0 means x-axis. On x-axis, y is equal to 0, and y is equal to 1. Y is equal to 1 parallel to x-axis. This is y is equal to 1 line, and x is equal to y. X is equal to, this is x is equal to y, this red line. X is equal to y, which is passing through the origin, and x is equal to 2 minus y. It is in the form x plus y is equal to 2, which is a line equation which is intersecting y-axis at this point and x-axis at this point and y-axis somewhere. Okay, so this is x is equal to 2 minus y line. Now we can identify this is x is equal to 2 minus y line. Now we have to identify the required region. So this is the required region. So this region we are going to split two sub-regions like a D1 and D2. We are splitting the total region into two sub-regions D1 and D2. So if you take D1, here what we are going to do, first integration with respect to x according to given limit. Then we have to take horizontal strip. In that region, we have to take first horizontal strip. So according to given limits, there will exist horizontal strip. So after changing the order, we have to take vertical strip becomes horizontal strip becomes vertical strip, and then we have to find the new limits. The new limits for the region D1 is x is equal to 0 to 1 and y is equal to 0 to x. So in region 1, here y is equal to 0 and here y is equal to x. So in region 1, that vertical strip which is sliding along via x-axis and extending from P to Q. Let it some P to Q. PQ is a vertical strip. So which is sliding along x-axis and extending up to P to Q. Okay. So by using this, we can find the limits. The limits are x is equal to 0 to 1 and y is equal to 0 to x. And in region 2, the new limits are x is equal to 1 to 2 and y is equal to 0 to 2 minus x. Then, so after finding new limits, we can evaluate the double integral. These are old limits, given limits 0 to 1, y to 2 minus y, xy, dx, dy. And by this is for region D1, this is for region D2. These are new limits. By taking new limits, we can evaluate the double integral. By using evaluation process, we can do it. Now I will show you one video regarding evaluation of change of order of integration. You can see this video. So here you can see the interior limits are x limit functions of x, then these limits belongs to y. Okay, so y is equal to 3 root x to y is equal to 2. So that the line, the curve of 3 root x is like this. It is starting from 0 to like this, and y is equal to 2. Y is equal to 2 means which is parallel to x-axis. This is y is equal to 2 line. And coming to the outer limits is 0 to 8. So here if these limits belongs to y, then exterior limits belongs to x. X is equal to 0 to 8. X is equal to 0 means y-axis x is equal to 8. Now the region where this blue shaded region is the required region of integration. Okay, the region which is bounded by all these four limits. So in these four limits, we have to find the new limits. By using these four limits, we have to find the new limits. You can see the blue shaded region is a required region. Here, first vertical strip will exist according to given problem. One vertical strip existing. On changing the order, that vertical strip becomes horizontal strip. So by using horizontal strip which is sliding on y-axis and extending from P to Q. Okay, by using new horizontal strip, we have to evaluate, we have to find the new limits. You can see the new limits. See here, horizontal strip. According to given problem, there will exist one vertical strip. Okay, so which is sliding on y is equal to 3 root x curve and extending from P to Q. Okay, so on changing the order, this vertical strip becomes horizontal strip. You can see horizontal strip. See, so in this you can see horizontal strip. So by using this horizontal strip, we have to find the limits, because the new limits. Okay, so it is sliding on y-axis and extending from P to Q. Now the new limits are 0 to 2, 0 to y cube and 0 to y cube. These limits belongs to x and these limits belongs to y. Then by using new limits, we can evaluate the double integral. So this is a topic we have discussed today. Thank you.